Okay, so today we're looking at the notes for factoring trinomials when our a value is 1. So that's how this folds, by the way. Should look like this. So first, a trinomial. That's just simply a 3-term polynomial, so 3 terms. Factors are the terms that multiply together that give you an expression. So they're the pieces in multiplication. So these pieces are the factors. And when you multiply, you get the product, which is the answer. And factoring a polynomial, we're breaking up or simplifying the polynomial into its factors. So breaking the polynomial into factors. Now, there's several different ways that you can do this. Me personally, I'm going to show you one particular method today, which is called the X box. So I'm going to write the steps here, and then we're going to follow along with here. So step number 1 is ABC. So here I'm going to write A, B, C. And these are the number values, the coefficients of each of the terms. So my a value always comes from the x squared, and today we're looking at it where the a value is going to be 1. My b value comes from the second term, the term that has the singular variable. And then my third term, c, the one without a variable. So that's my a, b, and c. Step number 2, draw an x. So you draw this x, and those of you that did the X game Delta Math assignment will be at an advantage here because you remember that when you did the X game, there was a number on top and a number on bottom, and you had to find the side numbers. We're going to do the same thing, but I'm going to show you where those numbers on top and bottom come from. The number on top is when you take the A value and you multiply it by the C value. So this is 1 times 5, which is 5. And then the bottom value is your B value, which is 6 in this case. Now, those of you that played the X game, you'll remember you needed 2 numbers that multiplied to the top but added to the bottom. So I always start with my factors of this number because there's going to be less of them. And my factors are going to be 1 and 5. Those are the only 2 values that when I multiply together, those are the only 2 whole numbers. Let me be a bit more specific. Those are the only 2 whole numbers when I multiply together that give me 5. So it's going to be a 5 and it's going to be a 1. Now, some kids are going to make a misconception, and I see that their A value and C value are the same thing. That's just a happy coincidence on this problem. It won't be like that all the time. So that's step number 2, and these are the values that you wanted in step number 2. Because you need them for step number 3, which is drawing a 2x2 box. By the way, if you can't figure it out, this method is called the X box method. So then you draw a box. Now, in your box, 2 of these are set up from the X. 2 of the boxes are set up from the original trinomial. Remember, when we were multiplying polynomials, we had numbers on the outside here that would multiply to get you the values on the inside. We're going to work our way out of that. So first, we're going to fill the box. This one right here, this box, is filled by that term. That x squared goes here. And then, and by the way, it's just the first term. So in problem number 2, it's also going to be x squared. Problem number 3, it would be 2x squared. All right, this bottom right box is going to be filled by this last term, which is 5. Now, these other two boxes are filled by these two, this 5 and this 1. When they come in and fill in here, they get a single value of the variable. So there'd be a 5x and a 1x. And to be very clear, it doesn't matter which order you write them here. 5 times 1 is 5. 1 times 5 is 5. Like, it doesn't matter the order here. And it also actually doesn't matter the order here. These two, these purple ones, they're going to matter big time. But these two, they don't really matter. They don't matter the order. Now we fill out the outside of the box, just like multiplying polynomials. And this is our fourth step. When we do the actual factoring and we find our binomials. So we're trying to find our binomial pieces. So I like to start with one that's guaranteed, okay? And there's a couple in here that are pretty much guaranteed, which is nice. So in this case, I'm actually going to start here in the top left. I know that this has to be x times x. That is the only way I can get x squared. Now, I'm going to work my way around this circle, or around this square, excuse me, and fill in all the other pieces that I need for this multiplication. So just like when I was multiplying polynomials, x times x, that's x squared. X times what gives me 1x? The only value that works there is 1. And then I work my way around. 1 times what gives me 5? Well, this is 5. And then I can confirm it here. Is 5 times x 5x? Yes. So if I was multiplying this as like a multiplying polynomial problem and everything's positive, then that's exactly what I'd have if I was multiplying these binomials. So these become my binomials. This is x plus 1. This is x plus 5. I want you to pause the video and get as far as you can using these steps into problem number 2. Try ABC. Try drawing the x. Try drawing the box. Try figuring out the binomials. You might not be able to get all the way. Okay, I'm going to walk through it. So if you get stuck at a certain part, go ahead and unpause the video and find the part that you get stuck at. Okay. In problem number 2, I'm going to go ahead and draw this line just to kind of give myself a little separation because I kind of went into problem number 2 there. Step number 1, ABC. So A, B, C. My A value is 1. My B value is -7. My C value is 12. Step number 2, I draw my X. I do A times C on the top, which is 12, and B on the bottom, which is -7. I find the only two values that multiply together that give me the top number, but also combine to give me the bottom number. So if I think of my factors of 12, I could have 1 and 12, 2 and 6, 3 and 4. All of these multiply to 12, 1 and 12, 2 and 6, 3 and 4. But when I combine them, only one makes 7, and that's here. 3 plus 4 is 7. So I have a 3 and I have a 4. But if I notice, looking at this problem, I don't need just a 7. I need a -7. So this 3 has to be negative, and this 4 has to be negative. And a negative times a negative makes a positive. So this all works out. Step number 3, draw my box. My first term goes in my top left box. My last term goes in my bottom right box. This -4x goes here. This -3x goes here. And again, if you have them flip-flop, that's okay. You'll find that we'll end up with the same answers. We'll end up with the same binomials. The only difference is we just might have them in a different order. And that's okay because it's multiplication. The order doesn't matter. It can flip-flop. Okay, so again, I always like to start off with the thing that I can guarantee. Like here with 12, I could have, again, 1 and 12, I could have 2 and 6, or I can have 3 and 4. Now, it's going to be obvious on which one I'm going to settle on, but when we get later on into some more complex problems, there might not be a guarantee. So I'm going to start with this x and x. And then again, I work my way around. X times what gives me negative 4? X. Well, a negative 4 will give me that. What times negative 4 will give me positive 12? Well, it has to be negative first to make a positive. And 4 times what gives me 12, which is 3. And then I confirm this last one. Negative 3 times x is negative 3x. That works. So my binomial is negative 3, x minus 4, x minus 3. So I separated this trinomial into these binomials. Just like in the last unit, we would multiply these binomials to get this trinomial. All right, and that's our notes for today's lesson on solving factoring trinomials when a is 1.